Good evening. Okay, so today let's try to look at this vertical projectile. I'm just going to try and focus mainly on the formulas and treat certain questions. And I will send you the questions on this video. I will show the questions and then solve them after that. So there are certain things that you need to always keep in your mind whenever you are dealing with a vertical projectile. And these things are very important because they help you to understand, and also they make your work to be easier. Number one, you must be able to draw the sketch of a diagram. Number two, you must always remember to write down the given valuables or values. Number three, you must always choose a positive direction. Then the last one, what you do, it is to solve. So now, the first thing that we are going to look at here are the formulas. The first formula, it is the formula of acceleration. So now, whenever they say calculate acceleration, I want you to always remember that acceleration is a is equals to delta v all over delta t. So, and the SI unit of acceleration is meters per second squared. So now this is a formula we use in order for us to calculate for acceleration. Now the other one is what you call velocity. So now when you are asked to calculate for a velocity is going to be small letter v is equals to delta x all over delta t, whereby delta x it is a displacement measured in meters, and then delta t it is time in seconds. Here on acceleration, delta v it is a velocity measured in meters per second, delta t it is a time in seconds. And always remember that time you have to always convert it to seconds. And then the SI unit of a velocity, it is meters per second. So now from here, let us try and look at the formulas that you will use in vertical projectile. The formulas that we use in vertical projectile. We have Vf is equals to Vi plus A multiplied by delta t. Vf here it is a final velocity, Vi it is an initial velocity, A is acceleration, delta t it is a time in seconds. The second one it is Vf squared is equals to Vi squared plus 2A delta x. So now here this formula you only use it when you have maybe they are asking you to calculate for displacement and they have given you velocity final and initial and also acceleration. So this one, the first one is different from the second one because the first one has time, the second one does not have time. So it has the displacement. That is the second formula. And the third one is delta x is equals to Vi delta t plus half a delta t squared. So now this one also it is when you are to calculate for displacement. They have given you initial velocity here. So each and every formula, if you can check, this one does not have a displacement, and then this one does not have a time. The third formula, it does not have one. It does not have the final velocity, but it has a displacement, initial velocity, and acceleration, and also time. Now the last one that we have, it is a delta x is equals to this equals to Vf plus Vi all over 2 multiply, sometimes they just put the brackets here, multiply by delta t. So these are the formulas that we are going to use whenever we are dealing with a vertical projectile. But now, how do we use these formulas? Let us first check, let us make an example. Okay, let us first look at our first example here. Our first example says a hot air balloon ascends with a constant velocity of 5 meters per second, meaning it goes where? It goes up. A ball is dropped from the hot air balloon at a height of 50 meters and falls vertically downwards the ground. Now, they say, determine the following. A, the distance between the hot air balloon and the ball after 2 seconds. Don't worry, I'm going to send you this a question. And then now, B says, determine the velocity of the ball when it reaches the ground. So now, the most important thing is what? Remember, let us write down what we are given. We are given initial velocity, which is 5 meters per second. That is our initial velocity when the hot air balloon is going up. Now, and we have what again? We have delta, because it is going up. We can use delta y is fine. When it goes horizontal, we use delta x. When it goes up vertical, we use delta y. So always remember that. So delta y is equals to how much? Is equals to 50 meters. And again, now what do we have? We have is delta t, which is 2 seconds. And not only this, because now we are dealing with a vertical projectile whereby the force of gravity is involved. Some educators use g, others use acceleration. It is 9,8 meters per second squared. It is always going where? It is always going out downwards. Then after writing all of this, now they say what? They want what? They want the distance between the hot air balloon and the ball after 2 seconds. Meaning here you are looking for delta y. You forget about this. Why am I saying this? Because the ball was dropped from the hot air balloon at 50 meters. But here they want the distance between the hot air balloon and the ball, meaning this one is not going to apply. We are looking for delta y. So you're gonna write delta y is equals to, which one can we use? So we have the initial time and acceleration. We can use this vi delta t plus half a delta t squared. We can use this this formula. But now remember that after this, what is important, it is always choose direction. So let us choose direction first. So now I'm gonna choose down as positive. I choose down as positive. If I choose up as positive, it means my 9.8 is going to be negative and my VI is going to be positive. But now I have chosen down as positive, which means my 9.8 is going to be positive and my VI is going to be negative. Always remember that, because this one, it is an initial velocity when the hot air balloon goes up. So if the direction I choose is against the motion of the initial velocity, it means now I'm going to have to put a negative sign here. which only shows the direction. Yeah. So like we said, let us use this formula: VI delta t plus half A delta t squared. So now what do we do here? Now we only have to substitute. Our VI, because now we set it down as positive, it simply means our VI is going to be negative. We're going to multiply by what? By our 2 seconds, which is time, plus half into our acceleration, which is our force of gravity. It is going to be 9,8, and then into what? Into time, which is a 2, which is 2 squared. So now these two, when you multiply, they will give you negative 10 plus, let us put this in our calculator first and check how much we get. We get 19.6. So now when we add these two, we will end up having what we call you will end up having what we say is 9.6 meters apart. So this is the distance that we have. This is the distance that we have, meaning here you can just say 9 meters apart, 9.6 meters apart. This it is the first question that we have to deal with here. And then from here, what do we say? They say the second question says what? Says it's letter B. It says the velocity of the ball when it reaches the ground. Meaning here they are looking for what? They are looking for V initial. V final. Remember we have a V initial, so they are looking for what? For V final. We're gonna say V final is gonna be equals to VF squared is equals to VI squared plus 2A delta Y. Why am I including delta Y now? This delta Y, it is not this part. It is that 50 meters, because now we are looking for the final velocity. We have the initial velocity. We are now looking for the final velocity. So what we're going to do here, we're going to say is remember we have chosen direction as what? As downwards, meaning we're going to have a minus 5 squared plus 2 into 9,8 into how much? Into 50. So now let us now calculate. This one is going to give us 25. Let us now calculate this two and check how much now we get. So now this two, this when you multiply it, you're gonna get how much? You're gonna get 980. So 980 plus 25. Let's check how much is 980 plus 25 is 980 plus 25. They give us how much? They give us 1,005. But we don't end here. We have to put the square root sign. So now after putting the square root sign, because it is a VF squared, we put square root sign here, square root sign here. Now our VF is going to be equal to how much? 31,70 meters per second. And now remember we have to what? Choose direction, because now it is positive, and then we choose here as positive. It means that this one, it is going where? It is going down. Now this is our final answer.